now let's talk about what happens when we have some variables underneath the radical. Everything we just did still applies. The only difference is that anytime you have a variable under the radicand, you're going to simplify them by finding out how many times you can factor out an x squared. And that's because the square root of x squared is just x. So every time you have an x squared, you can pull out an x in the front. So that means if you had the square root of x to the fourth, that means the square root of x squared times x squared. So you can pull out an x squared. So let's keep on looking at some examples of these. All right, so for the square root of 4x squared times the square root of 16x to the fourth. All right, so we are going to first just see what we can simplify. Instead of multiplying these straight across, let's think about what we know. We know that the square root of 4, the square root of x squared, we can break these all apart so that we can see that the square root of 4 and the square root of 16, those are perfect squares already. So that's 2, and the square root of 16 is 4. And then the square root of x squared is just x, and the square root of x to the fourth is x squared. So if you're a little bit confused about why is the square root of x to the fourth equal to x squared, why is that the case? Well, that's the case because the square root of x to the fourth, what that really means is that we have the square root of x squared, right? Because we can factor x squared times x squared is x to the fourth. We can just factor that. And what happens is the square root of x squared times the square root of x squared, this would give you an x, this would give you an x, and x times x is x squared. So that's just a little more information on why the square root of x to the fourth is x squared. All right, so let's keep on simplifying this one. So that would give us 8, and then we have x to the first times x to the second, which is x to the third power. Right, number 7. Let's try another one. I like to break the numbers apart, so if that helps you, you can do that too. All right, so we have 18 and 72. So I would say 18 can be broken down to the square root of 6 times the square root of 3. Or no, let's do the square root of 9 times the square root of 2 because 9 is a perfect square. And then we have the square root of x to the third. Then we have 72. So 72 is 9 times 8, so square root of 9, square root of 8, and then we have the square root of x to the fifth. Right, so now we can do our combining like we did before. So we have those 9s, then we have 8 times 2, which is great because that's 16. And then I'm actually going to show you something else we can do. So we have x to the third times x to the fifth. So I'm going to show you something pretty cool that happens here. So the square root of 9 times 9 is the square root of 81. 2 times 8 is 16. And then x to the third times x to the fifth is x to the eighth. So this is 9 times 4. Now x to the eighth, think about what we're doing here. How many x squareds can I get out of that, right? Well, this would be the square root of x squared times x squared times x squared times x squared one more time. So I'm running out of space here. Let's back that up just a little bit. All right, so I have 4 x squareds there. All right, I'm going to go ahead and multiply. 9 times 4 is 36. And I have 4 x squareds, so that's going to give me an x to the 4th power, because I pulled out an x 4 times.